We're going to see now the GY element or gyrator element. We're going to look at the block diagram notation for that element, as well as the bond graph notation that we're studying in a parallel way. So for doing a block diagram, we need to write the equations because block diagrams come from equations. Then we will derive the block diagram and we see the bond graph model as well. So over here. So here we have this electric motor that you see in here that it has been, this electric motor here has a voltage on the side and a current here, and what comes out is a torque and an angular velocity. But what we have in here is that you have that the effort, or what am I saying, this voltage E, this relates to the angular velocity of this. So E is the some motor constant, which we're going to call it R, times the angular velocity. So we have one equation that relates the voltage to the angular velocity, but we also have, on the other hand, the current multiplied by the torque. This is going to be the current multiplied by R, the modular here, is equal to the torque. So let's just put in here. Let's just put some labels here so that we remind ourselves when we write this equation, this is the input and this is the consequence of that input. And this would be in, but this would be out. This is important because we want to be able to write the block diagram from this. So we have this situation where we relate the voltage to the angular velocity. You see that right there, they are not the same family of variables because voltage is an effort variable and angular velocity is a flow variable. And we have a flow variable multiplied by the modulus gives us a torque, which this is also the this is the an output variable. What I would say to do the block diagram, so here's, let's write this, these are the let's just write properly the constitutive equations. Okay, so this is going to be our block diagram side. And this is going to be our bond graph side here. Okay, so here we go. In this case, you have two equations, and therefore on one side, on the electrical side, you have the current and the voltage, and on the other side you have the torque and the angular velocity. So let's say that we have, let's put these labels here. This is going to be my voltage here, E. This is the current, I. This is going to be the torque, and this is going to be the angular velocity. But you see, the first equation relates these two variables, and it says omega is into the element. gets E as an output. So it follows that this goes in, gets a transformation like this, multiplied by R, and out comes E. And in this other side, this is the input, gets multiplied by R, and out comes the torque in this direction. See? And this is my block diagram for these equations. So this is the way we write the block diagram for this. So this is a two-port element. On this side it has the torque and the angular velocity, and this one has a voltage and a current on the side. So if you use the bond graph notation, like if you say this is a gyrator element in here, and you'll see in here it has two variables. This has a modulus R over here, but I think it's a good idea to see what's going on with the equations here. You see on this side, E is the output. This would be the input. So if the input is a flow variable, let's say, when you say input to what? Just imagine yourself that you are infinitely small. There you are. And you look to your right over here, you're facing me. The first equation says omega in comes in. So I will draw it like this, see? This is omega, comes into the element. Out of the element gets E is out. So this is the E variable. And on the other side, over here, the other equation, if I look left, it says the current I is the one that comes in, which is represented by this flow variable. And what goes out is this torque. So what I'm trying to tell you is this is the bond graph representation of the very same thing. But what is important is that this bond graph is equivalent to this block diagram. Two different technologies. This guy would go into Simulink. This would go into CAMG. Okay? But what I would like to add to this is if we write the equations a little differently, we modify the block diagram and we modify the bond graph as well. So let me just, maybe I'll draw a line over here so it helps us with this. Oh, you need to pick this. So let's just pick this line over here. And let's try to rewrite this equation. If we rewrite the equation, I could say, E times 1 over R is equal to omega, like that. Or you could say that I is equal to 1 over R times tau. So why don't we just rewrite the equations. Use in different format. Okay, in order to do the block diagram of this, I would call your attention to defining what's the input and the output here. This is the result, so this is the output, and this is the input in this case. This, of course, is the output, and this is the input here. So how do we represent these equations? Also, we'll have it that in here you have two variables, and on the other side you're gonna have two variables too. And in this case, you will have the on this side you're gonna have the E and the I, and in this case you're gonna have tau and the angular velocity. But look at the equations. E is in, multiplies by 1 over r, like this, and produces omega, which is down here. And this other one has the current I is the result of tau multiplying by 1 over r and coming out with I. So this is the representation. If we rewrite the equations a little differently, and in this particular case, if you say, okay, look, this is a gy element, this is a gy element, and we just need to represent the what's on both sides. Gy element, and you have it two connections on each side, but it's very obvious that if you look, like I said, if first of all, the modulus in here is 1 over r. So compared with the previous one, we're getting the inverse. But in this case, if you were infinitesimally small right there, look to your right, what's coming in according to this equation. E is coming in, so you would have to do this. But omega is coming out, so you would have to do this. This would be omega, and this would be E. And on the other side, on this one, you have the I is the output of the torque times, see, this is the torque right here. The torque times 1 over r is going to give you I. See? So if this is the case, this bond graph model is equivalent to this block diagram and also to those equations. So this is what's equivalent. So conclusion, you can have a gy element with this form, will have this block diagram or this bond graph model. Or if you have it on this way, you will have this block diagram and this bond graph model. Now, once it's in this form, you have to learn how to get the equations from it. If you are given this, I ask you what does it mean? It means right here that omega multiplied by r produces E. So you see this comes in times r produces this, is the output. Or you have that tau is equal to I times r. So these two equations correspond to this bond graph model, which are the same equations. But you could, from this, you can very easily find that you have that E times 1 over R, E times 1 over R is equal to F omega. Or that you also have that tau is equal to the modulus no, tau, we need to be consistent. Put one side the electrical units and the other side the mechanical ones. So we cannot put it right there. We need to put the electrical ones on this side. So this is that I is equal to 1 over R times tau. See, tau times 1 over R equals I. So these equations correspond to this bond graph. So this is what we have for the GY element the result is either one on this form or one of this form.
Is there a preferred form?
No, not for this element. We prefer form for the integral form of the C elements on the I elements.